Hello and welcome back to Paideia classes. Hope you all are doing well. In this video, we will dive into the subsets of real number and explore how interval fits in as subsets of R. So let's get started. Let's discuss some number systems first. We already know what is set of natural numbers. We denote it by capital N letter, and they are the set 1, 2, 3, 4, and so on. It's an infinite set, and they basically we used it for counting and ordering. So we are familiar with this set, the set of natural numbers. Now we have also discussed about the set of rational number. So rational numbers are the numbers that can be expressed in terms of ratio or in terms of as a fractions of two integers, right? Where your denominator is non-zero. So Q is the set of rational number is what? The numbers that we can express in terms of P by Q, ratio of P and Q, where P and Q are integers and Q is not equal to 0. So for example, half, 2 by 4, minus half, minus 3 by 8, minus 3 by minus 8, or even 1, 2, 3, 4, because 0, because you can always write 1 as 1 by 1, 2 by 1, 3 by 1, 4 by 1, 0 by 1. So all these numbers are rational number. So natural numbers are rational number. Natural numbers are rational number. So natural numbers are basically subset of Q. Then integers are also rational numbers. So they are also subset of Q. And whole number is also a subset of rational number. Now let's see another set. So this is your N. This is Q. And you also know what is the set of integer. This is 0 plus minus 1 plus minus 2 and so on. Or you can also write it as minus 2, minus 1, 0, 1, 2 and so on. So this set is infinite from both sides. Okay. So all the natural numbers, integers, whole numbers are rational numbers. Now let's see a different type of sets. So we know we can denote this in the terms of P by Q, where Q is not equal to 0 and P and Q are integers. But there are some numbers which we cannot denote it in the form of P by Q. Those numbers are called irrational. For example, square root of 2, pi, or e, or 1 plus square root of root 2, root 3. All these are irrational numbers, the numbers that are not rational. We cannot express them in terms of P by Q, and they are non-repeating, non-terminating decimal expressions. What does it mean? Suppose you have this 1 by 2. If you write it in decimal form, you will get 0.5. If you have 1 by 4, you can write it as 0.25. And same goes for all the rationals. Not all the rationals, some rationals. Now, you may have this 1 by 3. So, you can write this as 0.333 dot or 0.3. So, rational number are two types. One that are terminating, other that are non-terminating but repeating. So after a certain point, they started repeating itself. For example, 1 by 7. So if you express 1 by 7 in the decimal form, you will get 0.142857 and then again 142857 and then again 142857. So after some time, it started repeating itself. It's a non-terminating decimal number, but after some points, it started terminating itself. So this is also a rational number. What happened in irrational? So here they were terminating. Here they are not terminating, but they are repeating itself. In irrational numbers, they are non-repeating and non-terminating decimal expression, and we call them irrational number. Second definition is that we cannot express them in the form of P by Q. Now let's see another set, which is the set of real numbers. The set of real numbers. So what is the set of real numbers? All the numbers that you have learned till now are real number. Any number that you can think of. 1, 2, minus 1, minus 2, 3 by 8, minus 3 by 4, root 2, e, 1 plus root 2, root 2 by 3, all these are real numbers. So what are real numbers? They are basically, the real numbers are basically rational and irrational numbers together. If we put them together in the set, we get the set of real numbers. So if you have this number line, any point represents a number. All the points on this rational line represent a number. And each number is real number. It could be a natural number, an integer, or rational or irrational. So all these things, rational, natural numbers, integers, whole numbers, they come in rational numbers. So we just need two numbers, rational and irrational, and together they form the set of real numbers. So from this discussion, we can say that Rn is the subset of real number because we have 1, 2, 3, 4, 5 on the number line, and then your whole number is also a subset of real number because 0 is also in R also. The set of rational number is subset of real number. The set of integers is subset of real number. Again, they are on number line -1, -2, -3, -4, and so on. And then the set of irrational number, which we represent by T, they are also subsets of R. So all the numbers that are present here are the subsets of real number. So we know root 2 is, the value of root 2 is what? 1.4142. 1, 3, 5, 6, 2, 3, 7, and so on. So it's not repeating, and it's also non-terminating. So this number would be present. Suppose this is 1.5. This would be somewhere here. We don't know exactly the position, but it could be somewhere here. 1.4142, right? So all these irrational number, rational number, they all are present in this set. Similarly, your pi is what? 3.141592653. So this would be, if this is 3.5, it could be somewhere around here, right? Now pi is not equal to 22 by 7. 22 by 7 is a rational number. 22 by 7 is a rational number because it satisfied the computation. You can write it in the form of P by Q, where P and Q both are integers, which are 22 and 7. This is not a rational number, but this is an approximation of the value pi. Okay. So we have discussed these, which is the set of natural numbers, which are 1, 2, 3, 4, 5, and so on. The sets of integers, which are continuing from minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3. So basically, we also take the negative numbers of 1, 2, 3, 4, 5 and include 0. And then the set of rational numbers, which we can write in the form of P by Q. So like half, 3 by 8, minus 1 by 2, 0, 1, minus 1, all of these numbers. And then we have the set of irrational numbers. So they are like root 2, e, 1 plus root 2, these type of numbers. And then set of real numbers are the collection together, q and t together, makes the set of real numbers. Now let's see the relation among these set with the set of real numbers and also among each other. Now see, 1, 2, 3, 4, 5. It is also belonging to 1, 2, 3, 4, 5. But 0 does not belong to one natural number, minus 1 does not belong to natural number, minus 2 does not belong to natural number. So this means all the element of the set N is also the element of the set Z, the set of integers. So N is a subset of Z. Now, if you look carefully, any integers, you can write it like this: minus 3 by 1, minus 2 by 1, minus 1 by 1, 0 by 1, 1 by 1, 2 by 1, 3 by 1. So basically, we can write this in the form of P by Q. Q is non-zero and P and Q both are integers. So this means all the integers are also the rational number. We can write them in the form of ratio or fraction. So all integers are also rational numbers. So natural number is subset of integers and integers is subset of rational number. So obviously rational number will also be subsets of rational number because all natural numbers are also rational numbers. You can write it like 1 by 1, 2 by 1, 3 by 1, 4 by 1, 5 by 1. Now we have the set of irrational. Okay. The set of rational number, let's first see this. The set of rational number, this would be the subset of the set of real number. Why? Because R is simply the collection of the elements from rational number and irrational number, Q and T. So the set of rational number will also be the subset of set of real number, and set of irrational number will also be subset of set of real number. Now N is a subset of Q, meaning natural numbers, all natural numbers are rational numbers. But N is not subset of the set of irrational number. Why? Because 1 belongs to N, right? But 1 does not belong to T because 1 is not an irrational number. It is, irrational number is what? Irrational number is something that is a real number and not rational, or you can say that you cannot write it in the form of c by q, or you can say that this is a non-terminating, non-repeating decimal number. So 1, you can write this in the form of 1 by 1, and therefore 1 is not a irrational number. So n is not a subset of irrational number. Okay. So yeah, simply you can say that your R is basically all the number systems that you have learned till now, till your class 10. All the number systems are subsets of this set of real numbers. There is sets which are greater than R, but the one that you have learned, N, Z, W, Q, T, all these are sets of subsets of real number. So obviously 1, 2, 3, they would also be subsets of real number. Why? Because 1, 2, 3, they are also in set of real. Okay. All these numbers are real numbers. That's it for today's video. In the next video, we will continue our discussion on subsets of real number and focus on interval as subsets of R. So that will be very interesting. And if you have any questions, please drop them in the comment section. Don't forget to like, share, and subscribe. Thank you for watching.